Okay, so if you can turn to page 1 of your packet, we're going to be talking about systems of equations in two variables. Now, I want you to keep notes along with what we're doing, and I'm going to do a couple with you, and then you're going to try some on your own. All right, so let's take a look at number 1. It says directions, solve each system of equations algebraically and graphically. So we're going to start here algebraically. Now, what we're trying to do is we're trying to figure out what values of x and y hold true in both of these two equations. Okay, so in order to do this, the first thing you want to do is you want to get either x or y by itself in one of the two equations. It doesn't matter. So you can get this x by itself, you can get this y by itself. I wouldn't try, if there's a square on it, I wouldn't try to get that one by itself. Or you can get this y by itself. So I'm just going to choose this y right here to get by itself just because it's easy enough for me to write on here. So I'm going to get that y by itself, I'm going to subtract 4 from both sides of the equation. So that leaves me with x squared minus 4 being equal to y. Now, since we have y by itself, if y is equal to x squared minus 4, okay, so y is equal to this, then what I'm allowed to do is I'm allowed to take what y is equal to and substitute it in for y into this other equation. Okay, so I'm just going to substitute. Let me see if I can fit that on here. Okay, I'm going to substitute what y is equal to in for y into the other equation. So now instead of this equation being x plus y equals negative 2, we will have x plus what y is equal to, x squared minus 4 being equal to negative 2. Okay, so again, what I did was I took what y was equal to and I substituted it in for y into this equation. So we have x plus x squared minus 4 equals negative 2. And now that we have an equation with just x's in it with one variable, we can solve. All right, so since we have an x squared in our equation, we know we're going to have to get one side of the equation set equal to 0. So I'm going to add 2 to both sides of the equation. And when I do, the right-hand side is equal to 0. Now on the left-hand side, let me just kind of rearrange this. We want to put our x squared term first, then our x term, and then we'll combine our numbers and put that. Okay, so I'm going to bring down the x squared, then the plus x, and then negative 4 plus 2 is negative 2. And here we go. So now, here we have a trinomial that, we want to factor. So we want to come up with two numbers that add to positive 1, because that's what's in front of our x, and multiply to negative 2. So let me set up my two sets of parentheses. We have an x and an x. And two numbers that add to positive 1 and multiply to negative 2 are positive 2 and negative 1. And I want to bring down my equals 0. Okay, I want to keep it in equation the whole time. All right, so then to solve this, I'm just going to make a t-chart. I'm actually going to make this big, and you'll see why in a minute. So on this side of the t-chart, I get x equals negative 2. And on this side of the t-chart, I get x equals positive 1. Now, the reason I made the t-chart big, I'm just going to kind of underline these because this is kind of like halfway to our answers. We were originally given equations with x's and y's. So what we need to do is, now that we know the x values, we need to figure out what y values correspond with each of these x values so that if we substituted it back into these equations, both equations would hold true. Okay, so if we want to solve for y, you can use any one of these two equations or even this one down here to solve for y. I'm going to use this one down here just because y already is by itself in this equation. So I'm going to rewrite this equation. The only difference is I'm just going to put y equals in front of it. So I'm going to rewrite y equals x squared minus 4 on both sides of the t-chart. Okay, so all I did was I just took this equation and I put it down here, and I'm going to use this equation to help me figure out what y value corresponds with an x value of negative 2. All right, so we'll have y equals. Now we know when we plug in a negative, we put that in parentheses. So negative 2 squared minus 4. And since negative 2 squared is positive 4, and 4 minus 4 is 0, then this is the y value that corresponds with the x value of negative 2. So you want to write that as a coordinate, right? X comma y. So I'm going to write that as negative 2 comma 0. Okay, so this is one of our solutions. If we took this solution and substituted it back into these equations, they would check out. Watch, I'll show you. If you take negative 2 and plug it in for x, and 0 and plug it in for y, isn't negative 2 plus 0 negative 2? Okay, so that checks. All right, let's also take this point and plug it in here. Negative 2 squared is positive 4. And if I take the 0 and plug it in for y, isn't 0 plus 4 also 4? So we'll have 4 equals 4. So that also checks out. All right, so this answer we know is definitely good. It works out for us. All right, now let's work on this side of the t-chart. We have x equals 1. So we're going to take this 1 and substitute it for the x and figure out what y value corresponds with it. So we'll have y equals, and now I'm just going to plug in. If it's positive, it doesn't matter if you put it in parentheses. If you want to, you can. That's up to you. And I'll bring down the minus 4. All right, so we have y equals. Well, since 1 squared is 1, and 1 minus 4 is negative 3, then, then the y value of negative 3 corresponds with the x value of positive 1. So I could write that as a coordinate as 1 comma negative 3. And if you took this point and substituted it in for x and for y into both equations, it would also check. All right, so the directions for number 1 say to solve each system algebraically and graphically. So we already solved the system algebraically. So what we're going to do is we're going to solve this graphically. Now, if we were to graph this first equation, right, when you have y to the first and x to the first, when you have an x to the first, this is going to graph to be a straight line. So it'll look, linear. And then here, if we have a y and an x squared is a quadratic. That's going to graph to be a parabola. So what we're really looking to do is we're just looking to find the points of intersection. We're looking for where this parabola and this line cross. All right, I'm going to start off graphing the parabola. So let's first, you can go to y equals in your calculator and, well, actually not yet. Let's take that equation and let's get y by itself. So if we want to get y by itself in this equation, let's get rid of this positive 4 that's on the same side of the equation. That's it. So those will cancel. And I'm going to actually just bring down the y equals on the left-hand side of the equation. It doesn't matter. And then I'm going to take this x squared minus 4 and bring it over here on the right. Okay, now here's our equation. So now I'm going to have you take out your calculator, and I'd like you to go to y equals and plug in x squared minus 4. Okay, so if you think about how a parabola works, right? I mean, a parabola that opens up, like this one right here, okay, when you go to plot the parabola, when you go to plot points, when you go to, your table of values and figure out which points you want to plot, like, let's just say we picked this point, this point, this point, and this one up here. If you were to connect those, it wouldn't really look like a parabola. We need the parabola. We need this point right here on the bottom is called the vertex. We want to include the vertex, and in addition, some points to the left of it, as well as some points to the right of it. That way it looks like a parabola. So when I went to y equals in my calculator and plugged in this equation, I went to my table of values, and this is what I first saw. Now, if we look at the points here, right, I mean, you were really concerned with these y values. What you'll see is, we have like a negative 3, and then it goes down to negative 4, and then it's going up, 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 up. So like if I were to plot these points, my parabola would look something like, okay, it first goes down from negative 3 to negative 4, then it goes back up to negative 3, up to 0, up to 5, up to 12. It's going to continue to go up. Now, to me, that's not really a good representation of the parabola. So what I'd like to try to do, we can see that this negative 4 right here, this negative 4 is the lowest y value that we're going to have on our graph. So I want to take that negative 4 and put it right in the middle of my table. So you may have to move, you may have to use the up and down arrow key. But if you notice now, see this negative 4? This is now in the middle of my table. So you'll see that, we go from a height of positive 5 down to 0, down to negative 3, down to negative 4, and then it's going to start going back up. So if we went down, 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 hit a minimum, and then went back up, what's going to happen is that is going to go down and up, and it's going to look like a parabola. Okay, so why don't we first write the table of values on our paper, and then after that, let's plot those points. Okay, so let me just make x and y, and I'm literally just copying this from my calculator. So we went from negative 3 all the way up until positive 3 as our domain, and the y values that correspond with that are, sorry, I messed that one up. That's a negative 5. Oh no, positive 5, I'm sorry. 0, negative 3, negative 4, negative 3, 0, and 5. Okay, so let's plot those. So we have negative 3, positive 5, negative 2, 0, negative 1, negative 3, 0, negative 4, and then a parabola heads back up in the same direction it went down. It's symmetric. So I'm going to connect those. Sorry, it's tough to draw on this thing. And I want to label that. So I'm going to label it with the equation I made it into, y equals x squared minus 4. If you wanted to label it with this original equation right there, you could do that too. That'd be fine. All right, now what we're going to do is we're going to graph this one, x plus y equals negative 2. So we're going to kind of do the same thing. Let's get y by itself in that equation. So in order to do that, let's subtract x from both sides. So that leaves me with y equals negative x minus 2. And you can clear out this equation from y1 into your calculator, and now you can plug in this equation. And I'm going to use the same domain as we did for our parabola. So, you don't have to, but I'm going to use from negative 3 up until positive 3. And let's see the x values that correspond, the y values that correspond with that. So I'm going to first just make a table of values. And we are going to plot those. All right, so we have negative 3, positive 1, negative 2, 0. Ooh, look, there's one point of intersection right there. Negative 1, negative 1, 0, negative 2, 1, negative 3. It looks like there's another point of intersection. 2, negative 4, and then 3, negative 5. Now, you should use a straight edge. I actually have a little trouble doing that because I don't see any lines. Let me just see if I see any lines. Oh, I lied. I found one. Okay, so I'm going to use my straight edge. I'm going to have to move that because that totally didn't line up to connect those points. And I want to make sure that I put arrows and label. I always like to make it label it the equation that I made it into. Now, if you do this, you would only get, let's say this was a 4-point question, you'd only get 2 out of 4 points for this question. You didn't actually answer the question. The answers are the points of intersection. So you'd want to write down the coordinates of this point and the coordinates of this point because those are the 2 points where our parabola intersects the line. So the coordinates of that first point are negative 2, 0. I'm going to make sure I put it in parentheses and put a comma around them. And the x comes before the y. And the other point is 1, negative 3. And box that off so you make it clear those are my answers. And if you look back up from our algebraic work, you'll see we got the same solutions. And even if you look in our table of values, look, negative 2, 0 matches up with negative 2, 0, and 1, negative 3 matches up with 1, negative 3. So there's so many different ways to check these systems of equations. Okay, so now if you can turn to page 4 of your packet, we're going to skip over 2 and 3 for now. You guys are going to try that for homework. Let's do this one together as well. Okay, now we said the first thing you want to do is you want to get either x or y by itself in one of the equations. But if you take a look at the first equation in number 4, look, y here is already by itself. Y is equal to x squared plus 4x plus 1. So since y is by itself, we can take this right here. We can take what y is equal to, and we can substitute it. I'm just going to write substitute. We can substitute it in for y into the other equation. So instead of having y minus 2x equals 1, we'll have all of this minus 2x equals 1. All right, so let's write that out. So we have x squared plus 4x plus 1, and then I'm going to write, right, I just substitute that in for y, then I'm going to write the rest of this next to it, so minus 2x, and then equals 1. Okay, so since we have an x squared in our equation, we want to get one side of the equation set equal to 0, so the easiest way to do that is just to subtract 1 from both sides. Okay, so the right-hand side of the equation now equals 0. Now on the left-hand side, I'm going to take the x squared and bring it down. And then we'll combine our like terms with everything else. All right, so now positive 4x and negative 2x combine to give us positive 2x. And actually, what happens with our numbers, the positive 1 and negative 1 cancel out. So we're left with x squared plus 2x equals 0. All right, so let me just get rid of that little dot there. All right, now if you want to factor, if you have two terms, a binomial, the only thing you could really do to factor is either, number 1, factor out a greatest common factor, or number 2, dots. Now this is definitely not dots. So it looks like here the only thing we can really do is just factor out a greatest common factor of an x. So if I factor out an x, then x squared divided by x is just x, so I'm going to put that here. Then let me bring down the plus sign, and 2x divided by x is just 2, right? We had a 2 and we had an x. We took the x out, so it leaves us with just 2. And then we'll bring down the equals 0. And from here, we'll make our t-chart. Okay, on the left-hand side of the t-chart, we get x equals 0. And on the right-hand side, we get x equals negative 2. All right, so let's figure out what y values correspond with these x values. All right, you can use either one of these two equations you want to solve for y. I'm actually going to use the second equation this time. I'm going to use, doesn't matter, you'll get the same answer either way. I'm going to use y minus 2x equals 1. Again, it doesn't matter which equation you choose, you'll get the same answer either way. All right, so then let's just substitute the x value of 0 in here, and let's see what y is equal to. So we'll have y minus 2 times 0 equals 1. Now, 2 times 0 is just 0, so it's almost like this isn't even here, right? So we're left with y equals 1. So when x is equal to 0, y is equal to 1. So we can write that coordinate of 0, 1. If we were to plug 0 in for x into both of these equations, and y in for 1 into both of these equations, you would get both sides of the equation to check out. All right, so let's finish on the other side. Now we're going to substitute in this x value of negative 2 into this equation. So we'll have y, actually, let me just erase this. It should be a minus sign, not an equal sign. So we'll have y minus 2 times negative 2 equals 1. Okay, so y, and then negative 2 times negative 2 is positive 4. So we have y plus 4 equals 1. And to get y by itself, let's just subtract 4 from both sides of the equation, leaving us with y equals negative 3. So when x equals -2, y equals -3. This is the other point that when you were to, if you were to plug it, into both of these two equations for x and y, you would get both sides of the equation to check out. All right, so let's solve number 4 graphically as well. We should get the same exact answers we did when we did it algebraically. All right, so let's start with our parabola right here. Now, y is already by itself, so that's nice for us. I'm just going to write the equation right here. And what I'm going to do is, in my calculator, I'm going to go to y1, and I'm going to plug this in. You can't even see the 1 because the graph is kind of blocking it. So let me see if I can kind of squeeze it in there. There we go. And remember, it's a parabola, so you want to make sure that that vertex, okay, the vertex is either its highest point or its lowest point. Since this is a positive x squared, right, we know our parabola is going to be opening up like this. So we're looking for the lowest y value that it hits, and then we want to graph a few points to the left of that, as well as a few points to the right of that. Okay, so anyway, when you go to your table of values, what you'll notice is that the lowest y value that our parabola hits is at -3. So that is going to go in the middle of our table of values. And then I'm just going to include 3 points above it and 3 points below it. So we have -3, -2, -4, 1, and -5, 6. And we'll do the same thing, 3 points to the right of it. So -1, -2, 0, 1, and 1, 6. All right, so just take a second and plot all of those points. And when you're done, you should have something that looks just like this. So we're going to connect. Do your best to make it look not so pointy. It's kind of hard sometimes. I missed one of the points there. And make sure you label your equation. Okay, you always want to label your graphs. And now we're ready to graph our line. Okay, so here's our linear equation. And in order to graph that, we want to get the y by itself first. So let me just rewrite this over here. Y equals, oh, sorry, I'm skipping steps here. Let me not do that. Y minus 2x equals 1. Okay, so we're going to add 2x to both sides of the equation. And that leaves us with y equals 2x plus 1. So you can go back to y equals in your calculator, and you can plug in this equation. And I'm going to use the same domain, so the same x values, that we used for our parabola. So make a table of values. And the x values we used went from -5 up until +1. So we'll do the same thing here. And just write down the y values that correspond with that. And we will graph it. Now, before you even graph it, we can see, look at this. So they both contain the point -2, -3, and they also contain the point 1, 0. So those should be our answers. Okay, I'm going to actually write those right off the bat. -2, -3, and 0, 1. Which, if we look back up in our algebraic work, we'll see those are the answers. All right, so let me just plot this equation right here, y equals 2x plus 1. So I'm going to just plot all these coordinates. So we have -5, -9, -4, -7, -3, -5. And you could see, look, the slope here. Do you guys remember y equals mx plus b? The slope is 2. That's why we're going up 2 over 1, up 2 over 1. And since our y-intercept is +1, it should cross through the y-axis right here, a +1. So let's just keep plotting the points. So, all right, now we have, where were we? Oh, we're at -2, -3, -1, -1, 0, 1, which we said was our y-intercept, and 1, 3. Okay, so you want to take your ruler, your straight edge. I'm going to do the best I can with the tools I have on here. And we are going to connect that. Okay, and then we can put arrows and label. I like to label this equation, the one we made it into, but if you do the original, that's fine. So we have y equals 2x plus 1. And again, we could see this is one point of intersection right here, which is 0, 1. We wrote it out and we boxed it off. Okay, make sure you do that. And then the other one is right here at -2, -3, which again we wrote out as our answer and we boxed it off.